Hey folks, welcome to Web Dev 2. So I'm going to jump straight into Git because I know there's a workshop coming up, and I will go through the introduction to the module next week. So I just wanted to start with Git because we're probably going to build a lot of stuff off of it. We're not going to dig too much into the collaborative features, which is where Git gets fun and funky at the same time. So today, a few slide decks. I'm going to walk through, what Git is from the start, what version control is, and also GitHub, same, very beginning, what is it? And look at some of the kind of, I don't want to say basic features because even the initial feature set that you learn of Git can get quite complicated, but take you on a journey kind of to where you will be proficient enough to use Git for your own projects. Well, hopefully anyway, and mention some of the collaborative features, which you may or may not end up using on the course, depending on how kind of your projects go and things like that. So yeah, so let's I suppose kick this off. So what is Git? So I wanted to try put this in kind of least kind of technical jargon as possible. So hopefully the examples make sense. But if we imagine we're working on a big group project for your class, everyone needs to contribute their part, but it's hard to keep track of who did what and when. So Git is like, an ultra kind of organized digital notebook that helps you and your classmates work together on a project without stepping on each other's toes, essentially. So it helps you keep track of every change you make in your project. So you're tracking changes. It's like taking snapshots of your work at different points in time that you can always go and view, revert to, take changes from. So if something goes wrong, you can go back to snapshots, fix it, or just even go and look at what the system looked like or the project looked like a year ago. So this makes Git a version control system. And, it also allows multiple people to work on the same project at the same time, helps everyone merge everyone's changes together, we'll say seamlessly, but that takes a bit of practice. And it looks like having, a magic wand that combines all your classmates' work contributions into one neat document. So when you look at a commit log in Git, you can just see the state of the project over time. And, there's all these different types of visualizations that can be created from Git history to kind of show people's involvement throughout the life cycle of the project. So it's also useful for backing up your project. If your computer crashes or you actually accidentally delete something, you can always get your work back from Git if you pushed it to a remote repository. If you have it on a local repository, you make a mistake locally, grand, fine. But if your hard drive dies and it's not on a remote repository, you'd probably have a bad time. So think of Git as your kind of trusty assistant, that keeps your project organized, helps you work with others, and ensures you never lose your hard work. Losing work is one of the most painful things you can do in work in industry. It happened to me once. I never wanted to happen again. Hard drive failures. They don't really happen too often these days. So Git is a version control system that enables collaboration and backup of typically code-based projects. I say code-based, you can have all different types of work inside Git. If you have kind of binary files and stuff, it can be quite hard to keep track of in Git. Still handy for a backup. So if you have like a PowerPoint, although they're PPTX at the moment, maybe it's okay. But it can be difficult to quantify the changes in documents like that. But for code, where it's typically UTF-8 encoded, you're kind of just working on text files at the end of the day, Git is perfect for something like that. But you can use it to back up anything. It just gets a bit slower and cumbersome than, say, something like a cloud-based backup if you have large files. Okay, so I realize I've said a lot of words there, like commit, version control, merge, and all these are going to come up in the slides as we go through them. And I'm going to try and just peel all those things back now and just kind of start it with what is a version control system. So you're writing a story on your computer, and every time you make a change, like adding a new paragraph or deleting a scene, you hit the save button. But what if you want to go back in time and see how your story looked a few days ago? There are tools that help you do it, but that's kind of where version control comes in. So if you take the story analogy and kind of push it onto working on a software system or platform, you can see it evolve over time using Git, see who changed what kind of thing and what changed. So version control is like a smart save button for your files. It keeps track of every change along with who changed it and when, creating a history of your work. So if you want to go back and look at the previous version of the story, you can. So along with, John, someone came in and changed this word from Y-O-U-R to Y-O-U''re. It would store, a version control system would typically store, this user John changed this, he changed it at this time, and any kind of accompanying metadata there as well. And, potentially John gave this message for the change, grammatical fix or something. So yeah. So a version control system, I suppose, in the realm of where we're talking, isn't just about saving different versions of your work. It helps you collaborate with others, or it can. Not all of them may, but for this, for the sake of software development, software engineering, version control system is a means for many different people to work on something at the same time. It's still difficult. You still have to be careful. You still potentially have to schedule work in different ways, to prevent conflicts, depending on how your company and projects are set up. But, let's just say you're writing a story, version control with a friend. Version control allows both of you to work on the same document without stepping on each other's toes, keeps track of the changes and help you merge your work together. So, Git will, or I suppose typically just version control systems will prevent you from overwriting someone's changes, because they're kind of time-based changes. And typically, there's, you can almost see it as like a log of changes, typically chronologically, that'll say, okay, well, you're trying to push a change to this file, but someone else has already changed it, and your changes seem to clash. And how version control systems do that is different across the systems. And if your changes clash, sometimes the version control system is going to say, oh yeah, no, I can merge that for you, no problem. And sometimes it just blocks you and says, you need to go and merge these files together yourself. So I have to look at what's in the repository and what's on my file itself, and I have to kind of merge them both together and put them back in. So that's kind of where you can cause issues if you do that wrong, because it's up to you then as a person to do that. But where that gets saved in kind of, or that gets alleviated in industry is, with the likes of kind of peer reviews of changes to code, let's say. So one thing you will always hear people saying when they talk about Git and, kind of like version control systems is repository or repo. It's one of the abbreviations that I actually use. A lot of abbreviations annoy me, but repo not so much. So a repository is where Git stores all the files and their complete history. It's like a folder on your computer that Git is watching closely. When you initialize a repository, you use git init, and Git starts tracking all the changes in this folder. So you can see on the left-hand side that we just have a directory here. It's a regular directory. There's nothing happening here. I have one file in there called README. And if I run git init in it here, you can see I get some logging out to say, okay, well, I've initialized an empty Git repository in here, and I can run git status. And now it says, oh, you're on the main branch, you have no commits, but I have this file that I'm not tracking. And it says, look, nothing is kind of added to commit, but untracked files are present. Use git add to track them. So now we're using Git, which is a command line tool. We can get visual with it as well if we like. I like to pair it back to just command line initially, just to kind of get a feel for it and how it's working. But we just have a directory called my project, which had one file in it. We've installed Git, which we will see later, and we've done git init. And that has now kind of made it a repository that tracks changes across all the files in there that you add to the repository. So, as you saw previous, Git told us that we had untracked files, and that untracked file was README. So what we're going to do is add that to the staging area. So we're going to do git add readme.md, and then we're going to run git status. You're going to see me run git status all the time. I run git status in my sleep, essentially. So you can see we have no commits yet, again, repeated, but we have changes ready to be committed, and that is, README. So in the previous slide, you can see this was red, the README, and now it's green. Now it's saying, okay, I am now aware of this new file. I could see it before, but I didn't really care about it. But now you've added it to me, into my staging area. It's ready to be committed to the repository. So the next thing we will do is commit that file to our repository by doing something like git commit -m. And so we're doing a git commit, and we're giving it a message. We might want it to be more helpful than that, but for now we'll just move on. And you can see we get some feedback to say, okay, well, you have committed README. One file has changed. One insertion typically means like one line is a bit inserted or one change. And we've created that file within the Git repository. So we put it in the staging area, we've committed it, we've done our job, and we do git status, and it says, well, look, you're on branch main, and you have nothing left to commit. Everything is there, everything is up to date from your file system and the Git repository. Where the Git repository, I will show you later, is just a record of what's in that directory. And it kind of, Git manages the difference between that record and what's actually on your file system, which is kind of neat. And if you come from older version control systems, pretty impressive, to be honest. All right. I've kind of intentionally just been using random words that you probably have never heard of before, just to start getting the lingo out there. So, I just randomly started talking about the staging area and commits. I am particularly random at times, but I'll go through what those are now. What is a staging area? So Git has something called a staging area or index. It's an intermediate area where commits can be formatted, reviewed, and is kind of essentially staging up your commit so you can review everything before you pull the trigger and commit it into your repository, and it's there forever. So one thing that sets Git apart from other tools is that it's possible to quickly stage some of your files for a commit without committing them all, and committing all modified files in your working directory. And typically, working directory, you can just think of that as the directory on your file system. The directory your files are in. That is my working directory. I'm working in there. Um, and that's kind of, a term that comes from, I suppose I would have heard it first in Unix or Linux, where you use the pwd command to print your working directory. That's where you are at the moment on the command line. So we stage them up. We do git status, and we're like, okay, I'm happy with those changes. I can potentially use a different visual tool to look at the changes. I can use the command line to look at the changes, and then we can commit them to the repository. So you can also ignore the staging area if you like. It's kind of, if you have lots of changes, it's good to chunk them together in different commits. So you might stage different files together and then commit them, as a singular change. The preferred workflow is to kind of commit as you go rather than let 400 changes build up. But it's easy to ignore the staging area, and this kind of gets into your workflow when you get used to kind of handling the changes in your brain, like what are you doing, what files are changed, and you're committing often, more often, more often, more often. So you just add a -a to your commit command in order to add all the changes to the files. And there's a link there to the official Git site. Git is a free open source project, and it has fairly terse documentation, I would say, but it has free ebooks available, and describes the staging area like in a little bit more detail than this, because this is essentially where I've got this material. Um, so one thing I've been mentioning over and over and over and over and over again is commit. So we commit changes to our repository, and these changes, can include new files, updated files, deleted files, or kind of renamed files. Once a change or a number of changes are committed as part of a commit, these changes become part of the history of the repository. We can view these changes using git log, and then we can kind of zoom in on those changes and show us like the diff, what changed, what was new, by using git show. So if I was to do a git log for that last commit that we kind of just committed, this is what I'll get over here. So you can see I, made this commit at this time into the main branch. We'll talk about branching later. And this is the message I put in, if you can remember. So, okay, great. One thing to take note of is this here. So this is the commit, and this is a hash of the commit. So a hash just means, the commit itself is passed through an algorithm that generates what we typically call in computer science, just a hash of that input, I suppose, where there's an algorithm run against it, and we get something that is quite unique, by a huge level of entropy, that we can use to identify commits inside a repository. And, that can be, when you think about Git and GitHub and all the projects in the world out there, this commit should be unique to this, which is kind of mind-boggling. So we can run, as I've showed up here, git show, and that's the output of this is over here. So typically when you start with Git, this will launch this in kind of a top style editor. And if you don't know, or viewer, sorry, and if you don't know anything about that, it's just that when you look at Git, you can see, when I do git log or git show, it kind of takes over your screen on your command line, and you see this little end here to signify that you're at the end. But you can just type Q, and it will close it down for quit, and you go back to your command line. Many people get stuck there. I've done a git log and now I'm stuck. Happy days. But it's something you get used to, and it's kind of navigating around. If you learn how to navigate around top, you can navigate around here. So I suppose just going back. So we've already committed. We're doing git log, and we use git show with the hash to show us more details about that commit. So there can be many changes in a commit. So a commit is a record of one or more changes committed to a repository, and it is ID'd via a hash within Git itself. In the last example, kind of these hashes can be shortened to the first 7 characters as well. So the following are kind of equivalent. So the last command we ran was git show. But we can just take the first 1, 2, 3, 4, 5, 6, 7. So these ones here. And we can run git show with the first 7 of the commit hash. And the entropy there is still really good. So I think that's typically what you see when you move around kind of GitHub and stuff. You'll see the small Git hash, and we haven't looked at GitHub yet, so don't worry about it. It's just web-based Git, and it's kind of like a web-based version of what you're looking at here. And you can see the output then kind of is the same as we were looking at on the previous screen. And yet you're stuck in there, so you press Q to get out of there. Happy days. Okay, so we now have our project, let's say, and we want to add 2 new files. So we want to add index.html and index.js. Great. So I've added those, and I run git status again. I love git status. Run it the whole time. And you can see, okay, we're on branch main. I have untracked files, and we'll come back to branch, don't worry. And it's saying, oh, I have these 3 files here. I'm like, what is this DS store? So you might get similar in Windows as well, or your IDE or whatever file editor you're using might put some metadata in the directory you're working in. Like a VS Code might sometimes put a .vs code directory in there. And that's what that is for OS X. So it's like a metadata file for the OS X file system. And you really don't want to be committing that to your Git repo. So we have that file. How do we just have to like ignore it all the time and hope we don't commit it by mistake? The answer, thankfully, is no. So we can use the idea of it's a configuration file called .gitignore. So it's all in one lowercase word. So it looks strange when you look at it first. But if you kind of take a look on the right hand side here, this is kind of a typical kind of git ignore that you might see where you're saying, okay, well, I don't want to commit logs, npm logs, no thanks. I don't want to have any process management in case I'm running a process in there. The operating system might put certain files in there, and if process terminates or something in an unhappy path, it might leave stuff lying around. Code coverage or whatever. So one thing you'd see output there, you'd see build, you'd see, I don't want my bytecode in my repository. It makes no sense. So a git ignore is a file that contains a list of files. So you can kind of say, like npm debug up here. And you can put a little star after it because actually those debug files date stamp themselves after that. And so it says, look, I don't want any files or directories named this with a wildcard at the end. I don't want any files or directories named logs. I don't want anything named star.log, star being a wildcard, so saying anything with .log at the end. So it will ignore a file named log, or it would ignore, the first one, this one here, would ignore a file named logs, if you had one. But typically you would have a directory named logs, and it would ignore that also. Okay. So one thing that's confusing to people kind of new to computer science and computers is that gitignore is a hidden file. In most operating systems, because it starts with a dot at the start, so full stop, whatever you want to call it. So if we take a look, here we're doing a list and we're not seeing our gitignore. But if we do a list all, we are seeing our git ignore, our ds store, and also, some navigation hooks the operating system leaves there, so you can kind of navigate around. And you typically don't see them, if you pull open a file explorer or whatever. So it's a hidden file, but when you're working in something like VS Code, it just shows them because it's a developer environment. It's like, oh yeah, we probably want to see hidden files here. We want to know what's going on. Whereas in your regular file system, showing hidden files would open it up to potentially, people that don't care. They're there deleting them, and they're like, why is this here? I'm just going to delete it, and stuff going wrong. So if you take a look at Windows, you can kind of show hidden items places, and it will show you files that are hidden. And OS X or Mac used to have more kind of options, more obvious, but they've kind of obfuscated them, I think. So the latest I've found is you have to press Command Shift and a dot, and it will change the left-hand side to here, where we can see our Git directory and our Git ignore. And we haven't talked about that Git directory yet, to be fair. If you can find a visual way to do that, let me know. I'll post it in here. Not everyone remembers shortcuts. And one thing about git ignores as well is that, you're not on your own writing these things. So like, you can start a project without one. And then when you're doing git status, you start seeing files you don't care about. So you just add them to your git ignore. But GitHub, which we haven't really talked about yet, they have a repository of all git ignores, not all git ignores, suggested git ignores for different projects. So this is just something, say, their developers do when they're, working on a project. So I'm starting up a Node.js project. I'm going to grab a very typical Node.js git ignore, throw it in there. And particularly at the start of the project, you're not going to ignore something that, by mistake. But typically these are very safe. I would use these a lot when you're creating a repository in something like a GitHub. They ask you, do you want to add one for a typical project? And then you can it's just a file, just a text file. You can keep adding things to the end as you go. If you notice that, some module or something that I'm using is leaving over some text files or log files, and I don't want them in my repository. You can just augment the git ignore. It just sits in your working directory, I suppose the root of your project directory. So after that slight diversion, we're going to go back and add a git ignore. So we're just going to create a file called git ignore and literally put the name of the file. Oh, I've done something here. There we go. So we're just going to put the name of the file in the git ignore, just like this, nothing magical. And we save that and we run git status again, and you can see ds store is gone, and it's saying, well, you should probably commit git ignore now, because your git ignore goes up to your repository. If you have a remote one and you share your repository around, the git ignore remains the same, because you don't want someone making a mistake putting in something you don't want in there. So we step through the process then of git status. We're now saying, okay, I'm kind of happy to stage all of these files. So we do git add -a, and just do git status, just as because we're learning. And you can see we've changed from red to green. That must be good. And now we're going to commit. So we're going to say git commit -m, adding too many files, tongue-in-cheek, whatever. So you can see we're creating 3 files here, and you can see we can run git status again, and we're on branch main again. nothing to commit, everything in your working directory is the same as the repository is expecting. So that whole process is just something that will just be in your muscle memory after you use Git for a while. You can use visual UI tools to do this. I kind of tend to stay away from them myself. I learned Git is kind of my second or third, probably third kind of version control system. And to learn it, I just wanted to use the command line, so I've always kind of stuck there. And the only reason I use a UI typically is, or graphical user interface, I suppose, is to work when merging and diffing, really. So seeing the difference between two files. So git log is also something that's quite useful. So if we git log what we just did there, we can see our first commit from earlier on, which we ran git show and all that kind of stuff on. And so you can see this happened on Thursday, and then on a Friday, I got back to work and I added too many files to the repo because it was Friday and I was out the door at 15:27. That'd be nice. But we can also grab, the first 7 up to the 5, yeah. And we can run our git show command. So you can see I authored this. You can see the time is the same. So, and you can see a lot more information than on our last git show. So you can see ds store was added to a git ignore file. That's also a new file. You can see index.html was added, and you can see the actual HTML that was in there. So not much. And index.js only had a console.log in there. So you can see the specific code in the git log. Well, in the git show, really. But okay. So as we've been kind of navigating around here, you've kind of probably noticed the .git folder within our working directory, or a repository, or a folder or directory, whatever we want to call it. So this is like kind of where the magic happens. This is where the history of your repository is kept. The difference between all the commits and the files. This is the history of your repository, and you probably shouldn't be in here. If you're new to Git, but it's good to know that it exists. So git init creates this Git folder, and you use git log to see your commit history, and git status to show you the current status of your repository. But if you're curious and you just go look in Git, you can see, there's a few different kind of things in there. You can set up Git hooks, which are things that happen when you do things with Git. So if I run a commit, I could set up a hook to run my tests locally. And then it just has objects and references, which I won't go into now. There's probably a lot of it I couldn't even go into because I'm just not interested. And I've never really had to be in the Git folder to debug a problem. That would be a bad day, and probably a day you just want to walk away from. I just don't see why that would ever happen. So don't do it. Okay, but I just wanted to show you it's there. It's kind of where the log is. It's where all the changes are. It's a very impressive system. So just to recap, so we used git init to turn a directory into a repository. We learned about the staging area, and we can add files to it to stage a commit. We can then commit these files to the repository. Git log will show us the log of commits, and each commit has a hash that can be shortened to 7. We can do git show to show us. We used git ignore to ignore files and folders. And so far, we've done all this kind of locally. I've kind of mentioned remote, but we will start talking about that next. So that's everything on a quick introduction. And now we'll kind of move into kind of the next area of Git. Okay, so The next part we're going to look at is a very kind of high level and quick introduction to what GitHub is. Um, and quite high level because it's just something that is kind of mentioned a lot. Um, and I know a lot of students kind of can, you know, kind of get frustrated with, oh, they expect us to know this for some reason. And it's completely understandable if you don't. Um, so let's move into it. So, what is GitHub? So, GitHub is a web based service that allows the hosting of remote Git repositories. It's become synonymous with collaboration on open source projects. It has features that integrate your Git repositories with the entire development lifecycle and release cycle. So CI/CD pipelines or GitHub Actions. If you do not know what they are, do not worry. If you do know what they are, it might help you put some context into what GitHub can do. GitHub can also act as an identity provider. You've signed into different things with GitHub. You can sign into tutors with GitHub, that kind of thing. And it's accessible via github.com. Here it is. So this is just a screenshot of GitHub, and it is a GitHub organization built around the 2024 version of this course. And you can see the modules in there, and we're tracking all of our modules in there. And this is how we store them, share them, work on them. And yeah, so we use GitHub to build, the HTIP. So remote. The key here is that GitHub hosts remote Git repositories. Git allows multiple repositories to connect to a remote repository. So this means that we can have a repository in GitHub and a repository on our laptop, and we can connect them together so that changes are distributed and kind of moved between each. So because it's remote and on a different system, so let's say the cloud, it allows you to use GitHub as a backup and a source of truth on personal projects. So you could, in theory, work on the same project on your home and work laptop, or your home computer, your work computer. Push stuff up, pull stuff down, before you leave work. Pull it down when you're at home, and be sad that you're working when you're at home. Or happy, whichever. But while also allowing, for collaboration on group projects. So as the diagram kind of leans towards, you can see we have a number of Git repositories kind of floating around this remote repository up here. And this symbol is just the symbol for Git. So nothing special there. But all these repositories are all different people, potentially. You could have them all on your computer just to have some fun. And you can see we can kind of all push and pull, essentially, is kind of the terminology you start using from this remote repository. And again, the remote repository sits on GitHub. So you can just imagine that as a server somewhere else. So are there other Git hosting services? Yes. So there's Bitbucket, there's SourceForge, there's GitHub, there's GitLab, and there's more. These are kind of the bigger ones right now. But they all offer, hosting of Git repositories, different features built around Git and the developer lifecycle. And, some of them can be self-hosted as well. So you can spin up GitLab on your own servers, internal to your organization, or you can just sign up for something like GitLab managed service. So you can sign up for GitHub managed service or Bitbucket managed service. And which means the compute is just controlled by someone else. You sign into a contract there of non-disclosure, that kind of thing, that your work will be safe and backed up, and you trust that they will do that. So I think I've only worked at one company that hosted their own Git repositories. And yeah, it was like it's seamless once you have someone that knows what they're doing with the hosting and backs it up. And I've probably found GitHub the easiest to work with because it's been so mature. Um, but why have I heard so much about GitHub? So back when Git was launched, don't know if I should say I was around then, but GitHubs just started appearing, because Git was being um, embraced by the open source community. And there's features inherent in Git that you can kind of email changes around to each other and use, um, and absorb them into a repository. And that's not kind of the way things work now. But that's kind of, I think, the way the Linux kernel was intended, like through user lists, you use Git to put changes into the kernel. But GitHub made it all a lot more seamless and kind of built features around those seemingly kind of more complicated features. So early adoption and popularity was one of the earliest platforms to offer Git hosting. So gain popularity due to its user-friendly interface. You pop open GitHub, you get your README straight away, which can confuse people. They think README is some sort of special file. It's not. It's just a file with words in it. Um, but GitHub put some importance on that, and then it became something more important. Feature-rich platform. I suppose just stepping back there, like, I don't think there's anything in Git that says you need to have a README. It's more of an evolved kind of idiom, in the world of software development, and GitHub helped push that forward. So feature-rich platform, as I mentioned, GitHub has a wide range of features beyond just being like, a server to put a repository on. You can create issues against specific lines in the repository, that you can then say, oh, I'm going to fix this, and it'll create a pull request, for you to put your changes into, or create a branch for you, and gives a ton of like code review capabilities, so someone can review my changes and not allow me merge them until they've reviewed them, and wikis. So wikis where good intentions go to die in the software world, but people do try to use them, and sometimes they do work out well. So this has kind of made GitHub a kind of a comprehensive platform for software development and collaboration. Collaboration being the big one. So yeah, social coding, developers can easily share their code. Open source has embraced Git a lot. My first open source contribution was through a project on GitHub. I haven't made many, but I've made some, mainly to fix a test or something here and there. The integration ecosystem. So there's a vast array of kind of third-party services. So continuous integration, continuous deployment, code analysis tools, project management that integrate with Git. You can integrate the likes of AWS with GitHub. You can integrate Azure. You can integrate all these things with GitHub. And it's amazing how central it has become to everyone's life on a day-to-day basis when you're a software engineer. So there has, GitHub has played a significant role in the growth of open source. Many major open source projects host their central hub for accessing and contributing to open source software. And we all gasped in 2018 when Microsoft acquired GitHub. We thought it was the end. Maybe it will be, who knows. But to be fair, Microsoft has pushed a lot on the open source side over the last few years. We all use and all like to use VS Code. So on our day-to-day basis, we're using a lot of Microsoft products, a ton of them. Even though we like to joke about the company from time to time, as engineers and technical, that has all kind of changed. Azure is a very kind of it's becoming quite dominant on the cloud side of things. AWS is still, I think, slightly ahead, and that's a Microsoft, cloud infrastructure. You use the Office suite, and now we use GitHub, and now we use VS Code, and we're quite happy using GitHub and VS Code. Well, I am anyway. So we can go take a look at some of the features on GitHub. So if I crash my computer, one moment, please. Um, so when you go to github.com, you can go to github/features, and you can see, oh, they have an AI assistant. Oh, what are the latest previews going on at GitHub? So you can see they launch different workspaces. When you're inside a repository, and if you have the correct account, you can say, oh, launch this in a workspace, and it will launch a virtual machine for you to work in the repository, which is kind of very cool. I've tried to use it with some classes every now and again. Sometimes it works, sometimes it doesn't, so it's getting there. So you can see there is, like, an AI section of GitHub as well, where it's kind of pushing you through all the latest developments there and kind of stuff that can come up. So you can see collaborative coding. You can see, look, oh, it does a nice UI or user interface to show the diff or the difference between code, pull requests, code reviews, automated code reviews. Everyone loves dark mode. I love that it's always listed as a feature places. I do use it, I suppose. CI/CD, which just means from a line of code on your laptop, you can basically use a lot of features on GitHub to just get that out to your deployment, to your production, and just host it. It could be hosted anywhere, and GitHub can control that whole process. And yeah, so lots of features. There's desktop clients and things like that, which I've had varying degrees of success with. But you can manage your projects, as I was just about to get to. Because you could build a project on GitHub around your repositories, and manage bugs, manage feature requests, manage project timelines inside of GitHub, and things like that. So yeah, it's not, there's just so much features there. I don't work for GitHub. I'm not pushing them, but it's just something that has just become so synonymous with working in a software company. Yeah, you just see it everywhere. Okay. Last part of GitHub is it kind of brought us the Octocats. And this has a varying importance to different people. I like Octocats. So it's just their mascot. You can see a lot of popularized ones around. And I think the story is some designer created the first one just for iStock to try make some money. GitHub started using it, and now you can go check out the Octodex, which I've left a little link there on GitHub, and have fun like I did making this slide. So that's a very quick introduction to GitHub. So where we will go to next is how Git and GitHub, locally and remotely, will work together. Okay. So I've introduced Git. I've introduced GitHub. And so let's just kind of look at how they kind of work together, like in day-to-day kind of real world kind of scenario. So we're going to be working through a bit of material here, and some of it comes from, it's just snippets from github.com/git guides. And as we talked about GitHub before, lots of features, but like their guides can be quite useful in figuring out how to use Git and how to set up Git and install it correctly as well. So we're going to install Git. So we're going to use the command line and Visual Studio Code. This means that if you're on Windows, you're going to use a program called Git Bash. And this might seem a bit strange to you, but essentially what the Git project ended up doing was it got so, well, actually, I don't want to infer how it felt because I don't know. But to me, it seems like, potentially the developers of Git didn't like working with Windows command line and Git. So they just created a port of a Linux shell, a limited one. It's not actually that bad. I've used it for a long time back in the day. Called Git Bash that lets you run the Bash shell on Windows as its own little kind of project or program. Now I know there is the Linux subsystem available for Windows now, but I would just recommend just use Git Bash when you're starting out, unless you're very clued in. Not very clued in, just kind of a bit more experience. So on other systems such as Linux, Mac OS, you can use the native terminal. I use iTerm on OS X. So you might see mine looks a bit different than yours, but download iTerm if you like. But if you choose to use the GitHub CLI, I may not talk to you. No, but I've just seen problems with students have with it. It's easy to get going on, and then their auth breaks and they don't know how they've authed, and good times. And don't install a graphical user interface program yet. We'll have Visual Studio Code. And after all of this, you're 100% free to make your own decisions. And of course, I will help. I say you're on your own, but I do try help. But sometimes the user interfaces can, especially for simpler projects, just destroy the opportunity for you to learn Git. So I'm not going to step through the install on every system. This guide is really good. It has, a different tab for Windows, Linux, and Mac. Go take a look at it, install Git. Hopefully it should be okay. If not, let me know. So once you do kind of configure or install Git, there's a couple of steps to configure your laptop. And I've just put some links here for you to go to do that. So we haven't touched GitHub yet. This is all local to your laptop. So set up your Git username as per getting started with Git. Set up your email address as well. And if you're starting out, don't worry too much about the config per repository, which you'll see in this documentation. And if you don't want to do any of that at all, just copy those lines I have in front of you here. It's worth reading kind of what's there. Some of it might confuse you, but feel free to gloss over the confusion. But you should at the end of it come out with, okay, I need to run git config global username, git config global user email. And these are the names and emails that appear on your commits. And you can confirm them with the bottom two commands to just print them back out to you. So hopefully that's your laptop now set up. And now you should download and install Visual Studio Code if you haven't already. So VS Code supports a host of Git features right out of the box. So there's the kind of Microsoft connection with GitHub. It's you don't have to install any extensions for Visual Studio Code to make Git a little bit easier. So what I'm showing here on the right hand side is just a quick view of the Git options within VS Code as is the default. So if I just go here, so we click here, and it's showing me there's one change potentially or something happening there. And you can see things like stashes, tags, my remote, which we'll get to, different branches, which we will also get to, and just the commits. You will see some other Git things on my screen. So it's like down here and down here, but they're extensions I've installed. I don't worry about them yet. Some of them give me some just different views on Git, which you can look at later. So now we have VS Code, we have Git installed, and we've kind of set up Git a small bit. Sign up for a GitHub account. You may already have one. Happy days. So before we do anything, I just wanted to talk quickly about public and private repositories. Because if you get it wrong, you could put something in a public repository that you don't want everyone to have, and someone will steal your ideas. I don't think it happens very often, but it's worth mentioning. So you can restrict who has access to a repository by choosing a repository's visibility, public or private. When you create a repository kind of public, it's out there. Everyone can see it on the internet. And when it's private, only me, only yourself or collaborators that you add to the repository. There's also the idea of an organizational wide view. So your company runs on GitHub. And when you make a private repository in there, typically it's visible to the entire organization. I think potentially you can hide it to yourself. Yeah, you can actually. Yeah, you can make it completely private as well, even if it is on an organization's GitHub account. So I recommend you kind of get into the habit of just creating all your repositories private initially. When GitHub launched first, you had to pay for private repositories. You don't anymore. You're also a student. So if like anything ever like that pops up, just there's usually a student program. But right now, GitHub allows you to have private repositories for free, which is pretty cool. And because you can always make the decision later to make them public, or even in 10 minutes. Or if you're asked by your lecturer or teacher to make them public, yeah, fire away. So here we are on GitHub, and if we want to create a repository, we can go to the repositories tab. Here, you can see I'm logged in as myself, github.com/username. Go to the repositories tab, and then there's the new button here. So the UI might change kind of a small bit every now and again, but should be pretty recent. So we click that, and all we want to do here, because we're going to step through this, you should step through this really. I'll probably just create a lab that links back to this slide deck. But we're going to just name it my first repository, give it a description, make it private, add a README, just let it put one in there, and you can select the git ignore for a node project. So hopefully I've mentioned all those things in the previous slide decks, so hopefully they make sense. And just don't worry about choosing a license right now. I'm not getting into that. So we create a repository, and the arrow is pointing to a little padlock to denote that the repository is private. Happy days. So this is what a repository looks like on GitHub. You can see a picture of me, my first repo, and you can see that the repository is private again. So we can see, yeah, it's just here, and we can see main branch. We have one branch, no tags. We can see an initial commit, which was made by me, but kind of by GitHub when they were creating this, where they added the git ignore and the README and committed it in, and then the README is given special kind of attention on the opening page of GitHub. And if you have multiple directories in your repository, as you click in through GitHub, if you had READMEs in there, it'll pop up the README in there, so you can dig in, and you can come across a README to explain what a directory is. But we won't get there yet. So here's my first repository created. Beautiful. All right. So we've signed up, via like, I don't know what you've used, maybe your college email address, or I've always used my personal email address with GitHub, because you can take that user to work with you. They add you to an organization, and then you come back out, and your GitHub stats are private, to the organization, but the stats themselves can be like, oh, John made this many commits today, can be seen by people in public, which may or may not be important to you. It's not really that important to me, to be honest. So we're inside GitHub, but we have nothing to kind of say link that to my computer, and this is where kind of GitHub CLI can come in and kind of be an intermediary here, or GitHub UI can come in and be an intermediary here. But I would just recommend that you take a step back and do the authentication that's recommended using SSH keys. If you don't know what an SSH key is, don't worry about it. like the documentation I put in front of you here um, will essentially step you through what that is. So essentially, you end up creating something on your computer, on your laptop, that identifies you, and it's kind of a cryptographic hash to identify you as who you are. And you have a public key on your machine and a private key on your machine. You put the public key into GitHub, and between the two of them, I suppose you also load the key into your SSH agent, and feel free to create a new key. It's cool. And this documentation should step you through it, and save this documentation, because no matter what, when I get a new laptop, I go through this and I go through these all the time. Um, and I always get it wrong first time. So these documents are handy to have. So after you do this, you can talk to repositories you've cloned. You can talk to repositories on GitHub that you own without typing in a username and password, without using some GitHub client that will confuse you in the future. All right. So I assume you've gone off and hit your head against the wall for 25 minutes to get the auth working. If not, you should. It's a very nice experience. But if you've made it this far, now it's time to clone your repository. So we have a repository on GitHub, and we can click the code button here. We want to click SSH, and we want to copy this here. So this is the Git kind of resource locator. So this is the kind of URL for our Git repository. So we copy that. Happy days. And what we do then is we go back to our computer, and a few steps here. So I'll get my trusty pen going again. We will first thing we'll do is run the command, say in our projects directory or wherever we are, git clone, and we just paste what we've copied from the previous, and you can see, oh, it's working. Okay, cloning into the first repository. Happy days. Then we change directory into there, because it pulls it down and it puts it in my first repo, because that's just what it's called remotely, so it just keeps the same name. If it already exists, it'll tell you. So you can see I changed directory into Git, and my command terminal has awareness of Git, because I'm using omyzsh on OS X. If you don't know what that is, don't worry about it for now. But you could change directory into here and you see none of this, and that's fine. Once you run git status, and it tells you you're on a branch, most likely main, and you've nothing to commit. And if I just do an ls or a tree here, ls is fine. You can see that I have just my readme in there. And if I do an ls-all, list all, you can see that the git directory is there, the git ignore is there, and the readme is there. So we've successfully cloned down the repository from GitHub, and it's all linked up. There's nothing for us to do now. We're happy. Great. So what we're going to do is open the directory or repository in VS Code, and here it is here. So I've opened it up and I've clicked the, I suppose initially I've probably clicked the Explorer section here, opened up README, made a change here, hit save, and now we want to open up the Git section. And you can see you're starting to see words you should recognize from the previous kind of conversations we've had. And you can see down here we have changes, and it says M, and it essentially kind of means modified. And you can see that up here too. So you can see like deep integration for VS Code and Git. It's kind of nice. And if there's some nuances here you're not seeing in yours, don't worry about it. I may have an extension, and once you get through this and you're like, oh, I liked the way that looked, just ping me and I'll send in some extensions. So yeah, so now we have those changes. So what we're going to do now is open up our terminal here, and we're going to run our good friend git status. So it says, okay, we're on branch main, your branch is up to date, but you do have changes, not staged for commit. So we've made a change, we've modified readme.md, and we've no changes to commit. So what I'm going to do is going to say, well, I'm going to stage and commit these at the same time because it's a one small change. I'm okay with not staging it. It makes no difference at the end of the day. From a log perspective, from a workflow perspective, it can make a difference. So git commit -a-m added more detail to the README, and we get some output to say the commit. We also can potentially use VS Code to sync our changes. So it says, okay, I see you have changes here, press sync, and it'll do a lot of this in the background for you. It'll probably print out what it's doing as well, but I think that destroys the learning experience. And it's good to have the learning experience when things go wrong. And that's why we're here, I suppose. I don't like the term sync. I don't like it for this case. And you can see now, number 4 here, that we have changes, added more detail to README after we've committed, ready to go out. So these are outgoing changes and they're ready to be pushed up to our repository. So this is a less busy screen. The last one was a bit busy. So you can see, we've done our git commit, as we've said, and now we're just going to do a git push. And nobody has changed anything on the repository that's up on GitHub. And you can see, okay, it's doing some stuff. It's doing some compression down around here, writing objects, and then it's sending them to github.com/johnrellis/myfirstrepo. And it's going main to main. So that has pushed up our changes. So we go to GitHub, refresh, and now you can see our changes there. So what has happened is, we've pulled down the repo, so we've cloned our repository, we've made changes and pushed them up. And this confirms that all the auth work we've done, all the authentication is correct, because we can make bidirectional changes. And this is where, if you use a public repository first, you can clone it fine, and then you can't push to it. It gets really confusing. So that's kind of one reason why to go private kind of first as well, to verify everything is nice and set up for you. Might cause you some pain in the short term, but I think you'll be better off in the long run. And now we just have time to celebrate our amazingness for putting changes into our first Git repository on GitHub. Let's give us a second to celebrate there. Okay, so a note on VS Code. So as I've been kind of mentioning, there is a plethora of useful Git extensions, but starting out, they can kind of be confusing and you might end up paying for one. Don't do that yet. I use very little when it comes to Git. I like the most I would use on VS Code is I really like that, the color coding of directories and stuff to tell me where there's new things that I've done. But I'm always using git status before I do a commit. You can see here we have a new file in green, modified is highlighted in yellow. Yeah, I'm boring maybe when it comes to it. But I've worked and distributed teams. I've never felt much of a need to visualize what's going on with Git, to be honest. Because Git gives you an opportunity to visualize things really nicely. And it's like, yeah, whatever. But here's my mini Git cheat sheet. So put this somewhere in the bin if you want, don't mind. But we git clone with a git URL to clone a repository from Git. Git status is now in your muscle memory forever. Check the status of your repo locally. Git add -a or git add readme to add a specific file. -a will just add everything that's been changed, or new files will just all be added to be committed. Git commit -a-m adds all new staged files and unstaged modifications to existing files. That's a bit of a chunk. It'll kind of make sense when you use it a bit more. And of course, change your message from that. I was just trying to be clever in putting the lesson into the message, but I probably confused you more. And then git push will just push everything up to the repo you've cloned. Now, when you start out with Git, different versions of Git, like I have it on my laptop so long and I've configured it, sometimes what can happen is you'll get a message to say, I don't know which branch you want to push it to and stuff like that, and we'll talk about branches. And typically going with what the command line is telling you to do, it'll give you an option to say, you should probably do it this way, just do it, and then you can git push up and down forever on that local repository through your remote. So just don't be too scared if you see something, especially when you're starting out with a simple repository. Make your mistakes then. So yeah, so this is the simple life. My general workflow for years, day to day. You get in, you're working on a project, you get pulled to pull down the changes. You make a group of related changes. Maybe you'd run your tests as well, actually locally. But we haven't talked about anything like that. Git status, I'd add, -a if new files need to be added, but it'll do no harm if you just end up running that all the time before you commit. Then I would commit with a message to say a bug fix, so the code no longer explodes, and git push. And that can get you a long way, especially on like personal projects where there's no confusion about merging and things like that. So of course there's nuance you can mix in there, and some people, something I've done in a command there might really annoy them. If they're very kind of on the semantics at Git. But this has served me well. You can get going it ends up being a kind of a unidirectional workflow, and you're just kind of using Git for a backup. But it is useful to commit more often than not, even if you're just working locally. But also be careful. So you can use git checkout and give it the file name. So git checkout readme.md and undo all the changes since the last commit on that file, which might make you sad. One thing that will make you quite sad if you don't do it right, I generally run this when I'm kind of working with different Git repositories and backups of them and things like that, is the git reset --hard, undo all the changes since the last commit. I think it's unstaged changes, but it could be all changes. And it can be handy when you pull down a repo, muck around with it a bit, see what happens, and then do git reset hard. But it can also remove a day's work if you're not careful. So don't put that in your muscle memory. So when something has gone wrong, a multitude of things can go wrong when working on projects that have multiple collaborators. Typically around just incorrect merging or commits or detached trees, something. But take your time. In industry, all changes are peer reviewed, so silly mistakes are usually caught. Kind of what I end up doing, like if I'm just like, I have no idea what has happened with Git here. If you feel like there's a lot that could go wrong, like you're going to go merge something or you're going to go rebase something, and you feel there's a lot that could go wrong with that Git action that you're going to do, I shouldn't have used the word Git action here because that means something else. You make a copy of the repository locally. So you can see down the bottom right, I have my repo copy and 2 and 3. So you can go into either of those and they will all operate the same as the other kind of cloned repos, and you can push up and down because the Git repo is embedded in them. But I would perform the actions locally in one of the copies. I just use the copy as a backup just in case, and just see if what I expected to happen actually happens. Because sometimes you can run something and you're like, I expect this to happen, and then Git does something else and your stomach sinks and you're just like, it's going to be a good day. But I've never gone into a situation I couldn't work my way out of with Git. It's incredibly logical. Even though sometimes it doesn't feel like it, it is actually incredibly logical. So yeah. So for some resources, we have the cheat sheet. If mine's not good enough for you, which it isn't, you end up kind of with cheat sheets from like the likes of GitHub, or Atlassian, another big. They're kind of the Bitbucket people, but big software house. Okay, so the next thing we're going to look at is some features of Git. So we've looked at Git locally, we've looked at GitHub, we've looked at the interaction of GitHub with your local computer, and now I just want to mention some features, not go into them in big depth, because there's plenty of stuff out there on how to use them, and we'll play around a bit with them in a lab or whatever, it'll be fine, just to give you an idea of what's going on. So, we're not going to deep dive too much today on this one. We're going to go look at branching and merging and honestly just say a few words about remote branches and pull requests. So branching and merging is the first thing Git homepage when you go into what is Git tells you about. So it's important. So in Git, all your work is done on a branch. When you create a repository, a main branch is created. This main branch was once called master, but that's less common now. It's more main branch. Up to now, you have been staging and committing all on the main branch. Typically, a branch is created from a commit on main, for example, to create a new feature or bug fix. So from main, we create a branch and it starts a new branch of development, often referred to as feature branching. So once the feature is complete or a bug is fixed, we can then merge that branch back into main. Between such time, others may have augmented main. And if that happens and we have conflicts, then we need to merge and manage those conflicts and then push back up. Which typically, like if there is ever a merge conflict, like a lot of what you see is just, oh, I needed to move a line up or down. It can be quite straightforward. So what is a kind of a simple way of branching? So if we see, let's take a look here. I'll give you a link to these examples as well. But we have a main branch. So this is everything we've been working on. And, these little dots are commits. So we've been working along, and we've created a commit, and then we've tagged that commit as, say, release 1. Haven't talked about tags yet, so it's really just a way of saying this commit represents version 1.0.0. And it literally is kind of like a tag. And you can go look at a tag or a commit and it will show you the whole repository at that time. So let's just say this tag is just a regular commit. Don't worry about it too much. So now we have version 1 done. And we're like, okay, someone has come back after using version 1 and they want us to create a new feature. So I'm going to git branch, create a feature branch, call it after the ticket or so Jira is just like a ticketing system. Well, it's more of it tries to be an agile process management system where you create issues, bugs, features, and that kind of thing in it. And it's pretty good at it. People loathe, whatever. But you end up spending a lot of time in Jira. We won't go into it yet. You'll have enough time to do that in the future. So we've started working on that feature and, we've committed 3 times on that feature. So now we've said, okay, I'm going to merge that in here. So there's multiple kind of different ways of kind of merging. You can do a single merge commit or everything can just be hoisted in as different commits. But we've now merged this feature in here and we've tagged this now as 1.1.0 and say, we release that out. And now we're back on the branch main and they find a problem and we go, oh no. So we now do a kind of a hot fix or a bug fix kind of branch. And, merge it back in. Someone has committed to master here, or main, excuse me, which is probably not intentional on my part, but it's there. But I'll show you in the next example what happens there. So let's just say we do our 1.1.1 hotfix and we release it again as 1.2.0. So that's a very simple kind of linear. But if we take a look at maybe like a more advanced one, so you can see we're on main again and we have our 1.0.0 tag, and developer 1 branches off to create another feature, and developer A branches off to create another feature entirely. Developer 1 gets there first, and then developer 2 gets there and kind of, merges in, and the changes all merge together. Let's see how many boxes I can draw on a slide. And they're all merged together, and sometimes there can be conflicts, and that's where you might get on the phone or on Slack or on Zoom with the other developer. If there's a problem, you'll say, oh, I'm trying to merge this in, but I see this. Or it might just be a case of, a lot of the time, it's kind of, you made changes in the same place. So the developer might have a function where you put your function, and Git just can't with confidence say, I can merge these automatically. So you can see there's 2 developers branching off, creating 2 feature branches, and then they merge in, and then they're all back in the same code base, and 1.1.0 gets released again. So kind of the same example as last time, but just with another branch being created. And all that really is, it's all metadata around, I have created a branch from this commit, and now I'm kind of committing, and now I want to bring it back into main. So what that actually looks like in real life. So we have our first repository here, and I'm going to, well, actually, just taking it slowly again. We have our first repository here, and I have the file explorer over here, so you can see what's happening too. So you can see we just have our README. We have our git ignore, and we have our git here. They're fine, forget about them. But you can see we have our README here. So I'm going to do a git checkout -b, my first branch. So what I've done here with the -b is said, if this branch does not exist, create it for me. So that's what it did. It said switch to a new branch called my first branch. You see, nothing has happened here really, because there was no changes. There's nothing. We've just moved to a new branch. So now we've created new text file down here, and we run git status. Great. So you can see we're on my first branch. As I said, you may or may not have this information here, depending on what terminal you're using and what shell you're using. But don't worry about it. Git status is your friend. It'll tell you the truth. So you can see we have some untracked files. So I add that file in a lazy way, just saying git add everything, grand, whatever. And say git commit -m added new file. And now I run git status, and you can see on branch, my first branch. And it's like, okay, now I have new file.txt in here. So we're now going to commit ahead of our main branch, but the main branch has no idea that new file.txt exists. So here we are back here. So we're running git status again. Yes, we're on our first branch, and everything is the same. So this is how we ended the last slide. So what I'm going to do is go back to main, and you run git checkout main. And if you keep the file system open, you will see your file disappear. Now, to me, this is what made Git make sense to me. Like when you could kind of change between branches programmatically and see the file system change in front of your eyes, not some metadata directory somewhere, something very real change. It kind of gave me peace of mind that I could always see what was going on. I don't know if that was the intention of the creators of Git, but it really gave me an understanding of how this works. So now we're sitting on the main branch, and my new file.txt nowhere to be seen. So I'm going to say, okay, git merge my first branch, and it's doing a fast forward, which means it's just trying to merge everything in without really thinking about it and hoping to get away with it. And if it doesn't get away with it, it'll tell you. So it's created a new file, and it's created my new file. And now this, our new file.txt has reappeared. So it was like it's sitting somewhere in, your Git folder. .git, that whole file is sitting there, because it's a new file. So there, the diffs are then stored after that. But and Git is going to hoist that out then, and now it's on your file system. So it's now on the main branch, and it's on your my first branch. And we can run our git log, and you can see we have our initial commit, which was, I think, from GitHub itself. We added more detail to the README, and then we added our new file. So you can see, apart from up here, that has some metadata on where this file came from. So it came from my first branch. If you didn't see that, you would just see a log and you see a load of changes, and you wouldn't have known that I had branched off. And why do you need to know? Is kind of the thing, you don't, if you're reviewing the history here. You can then run git branch, and it'll show you your currently existing branches. And you type Q to get out of this here. Okay, so that branch has been merged. You can see it all looks like one consistent story in git log. So now I can just delete the branch. It serves no more purpose. I'm keeping everything clean and tidy here, and Git is nice and tells me the first branch was deleted. Do git branch again, and all I can see is main. So just to recap there, we created a new branch called my first branch. We did a git checkout -b, my first branch. Oops. This one here. And -b, as I mentioned, creates and switches to the branch. If you try and check out a branch that doesn't exist, it'll just say it doesn't exist. And -b will create it for you. So git status will tell you what branch you're on, our good friend. So we created a new file and added it and committed it to the first branch. Create file, git add, git commit. We switched back to main. We did git checkout main. Newer versions of Git, you can actually go with git switch, which, is a bit more user-friendly, I think. And you can do git switch -1 to switch back to your last branch. So you can imagine you're in, a workflow of a git, branch from main, and then, you're doing git switch -1 to keep switching between main and that branch. It might be something to get into your kind of, muscle memory or whatever. It's not something I do very often, but it's just because I'm more used to the older way of doing things, but git switch looks really useful. And remember, we noticed the file system changes. We switched branches and the file system actually changed. And, there's not something hidden in the depths of Git. You can actually look at your file system, and this is the current state of the repository. If you do git status and there's no changes, excellent. So we then merged our branch into main, git merge. We then deleted the branch. We viewed available branches with git branch, and we used git log. So yeah. We can use Q to quit from the log and the branch view. So just to quickly mention Git and remote branches on GitHub. So if we take a look here on the left-hand side, we've checked out another branch. This is just mumbo jumbo to create a file and put some text in there. So that doesn't make sense, don't worry. Git add -a, and we've added a new second file. And then we try run git push. Now we're on a branch here. So it says the current branch, another branch, has no upstream branch. To push the current branch and set the remote as upstream, use this. So you want to push, and you want to set the upstream in the origin to another branch. And you can change your Git settings for this to happen automatically as well. But in this instance, I just copy, paste, push it up. It does its thing. And then it tells me, well, you can create a pull request if you like. and we'll show you that next. But if we open up Git, we can now click here and we see that we have another branch. And you can even see it goes, hey, you have this new branch. Do you want to create a pull request to put it into master? And we can select our branch here, and GitHub will augment itself to show you what the repository looks like for this branch. So here it is here. So if you go ahead and create a pull request, so if I go back here, you can see here we have compare and pull request. This is what opens up. So what is a pull request? So a pull request is me working on a project that has multiple developers on it. So I've created a branch, I've made some changes, and now I'm creating a pull request to ask the team, can I now put this into the main branch? And so what can happen in this scenario is I put some information in here. I'd probably put the bug number here, and you try to link it up with my bug tracking system and that kind of stuff. And you can set it up so that I can only merge when someone on a particular team approves this, the platform team, the DevOps team, the security team. And then once I get the approval, I get a notification and I can merge it back in, and GitHub will merge it in, and then you can pull down the changes on your main branch locally, and there you are. So I won't go into it massive detail. Just wanted you to know that they exist. Like you could potentially go through college completely without using pull requests at all, which is kind of strange. But maybe we can get into a place where we have group projects, or just a group project to learn GitHub. But it's something that I find comes very naturally to people. Although some people obviously can be very nervous about putting their code up there and then someone reviewing it and then coming back to them. But my general rule is when someone is new, you talk to them about the feedback, or you give the feedback and then reach out to them and kind of go, what do you think of that feedback? Is that okay? I can explain it to you, kind of thing. So it becomes more of a managerial exercise for like the senior developers or your team leads to kind of do. But yeah, so where to next? So check out Git SEM About. It has some of the material that I've covered here. There's a free ebook called Pro Git, which I have definitely used in the past. Discover and have a look what a Git tag is, why you would use them. And there's some good videos there from Visual Studio Code as well on how to use Git. And just different kind of links that might be interesting to you go see a gist on GitHub. And also then that tree graph I was using to show you the commits and the branches is available on the last link. Okay, so the next thing I want to talk about very briefly. So we've done like we're touching on broad areas here just to kind of get into an introduction into all the stuff Git and gitops and GitHub can do. Sorry. So what I'm going to talk about now is the whole idea of operations driven by Git, and you'll come across a lot of this in later modules or in your first internship or in your jobs or whatever. It's the day-to-day life of using Git and GitHub to get projects deployed. So yeah, let's talk about those now. I'm going to go through one specific example. I'm not going to melt your head with all the operations that can happen with Git. So we're not going to cover the entire scope of Git-driven operations, but we're going to use Git to auto-deploy our Dotify site that we did in WebDev 1 to Netlify. So first things first, I am going to put a link in there for code, which I forgot to do, but I will do that in a moment and push it up to tutors so you'll be able to see it. Unzip and open it in VS Code. And it might be handy to try get VS Code launching from your command line. It's a good workflow to have. And now create a new private repository on GitHub. So you've downloaded the zip locally, you have it up in VS Code. Great, that's local to your computer. Now on GitHub, go and create a private repository. And name it Dotify, name it Dotify Lab, name it whatever you think. But do not add a README or license file. So we want the repository to be empty, completely empty, okay? That's important. You'll get stuck-ish if you put something in there. I don't want to cover that case now. But yeah. So back in VS Code, we can do a git init in the code we've just unzipped. And we're just going to add everything and we're going to commit everything. Happy days. And then we're going to run git push. And we're going to go, wait a minute. I've just created something locally. I've created something remote, but I've never really connected them together. And that's what Git is telling us. There's no configured push destination. So we're like, okay. It didn't work. And that's why. There's no relationship between them. So if you go back to your empty repository, this is why it's kind of useful to just keep it completely empty. Git just gives you, GitHub gives you some advice. If create a new repository locally, or if you have some existing code, you can do this. So we're kind of doing a mixture, I suppose, of these, but we've done it over here. So we've said, just to highlight here, here's our Git URL. We say git remote add origin and our Git URL here, and we're pushing up git push to the origin main. We already have a main branch, so we don't need to create one like we're doing over here. And then we're running git status. And now we've pushed everything up. And all subsequent pushes can just do git push. You don't need to do origin main all the time. I think if you do, it's okay, but you might get confused when you're on a different branch and do it. So just keeping it simple, git push. And Git will tell you if there's something kind of weird going on. So refresh GitHub, and you can see all your files from Dotify have now appeared on GitHub, which is excellent. Great. So we now have all our code up on GitHub. Let's have a martini and move on. So next thing is sign up for a starter Netlify account with your GitHub identity. And then once you do that, you want to add a new site. So you go to sites, add a new site, and then import an existing project. So we can pick deploy with GitHub, and you will very likely just get a pop-up window to say, do you want to connect this to your GitHub account if you're already signed in with GitHub? It's doing it for you. So it should just be a case of accepting. If you're not happy with that, or you're confused by it, or something happens, let me know. So you'll actually then get a nice warm and fuzzy, or maybe you'll be scared of how much this can see, list of your repositories. So you can say, okay, I'm going to find my Dotify one and select that. Confirm all the settings are correct. So you want the branch to deploy to be main. You want the build command to be 11t, and you also want the publish directory to be site. So you can see over here, I suppose this should be underscore site as well, if I want to be completely correct. So you can augment some settings there and augment your build settings there. So now we will deploy, and we will press the lovely deploy button, deploy Dotify. So I've changed the name of my repo here, yeah, in the site name, yeah, okay, I didn't mention that. So you can change your site name when you're spinning up your project, and you can do it later on as well, so don't worry if you don't. deploy it, and your app will start building. So this might be the first time you're seeing something like this build. So essentially what it's going to do, it's going to run 11t. Well, actually what it's going to do is going to pull down your repository from GitHub to a build server on 11t. It could be a container, it could be a serverless function. On Netlify, and it will run 11t against it, and it will build. As you can see down in the corner here, we have building. And it failed. So you can see, we go into our log, we can see, well, first we can see failed up here, and then we can see failed down here. And we go to the next page, just to zoom in a bit more, you can see the 11t command is not found. So why did this happen? So build agents are typically a virtual machine or a container with a basic Linux install. So 11t is not installed. Some build agents allow you to set up an install phase, but this can be expensive when running builds on commits. A lot of network traffic, different types of things happen there. An alternative is to install 11t in our local node modules and run it from there with a custom npm script. And we'll do that now. So add a package JSON to your project and install 11t locally. So run npm init and you'll get some output and just agree to it. And then run npm install 11t. So that exact command there. So once you run that, package lock will actually probably get created as well. It may already be there. We want to open up package JSON and add in the scripts section a key for build and a value of exactly what's there. So node module /bin/11t. So then, actually, I'll just get rid of myself because the green is gone. So yeah, so just back at that slide with the green package JSON there. So we're just adding that build line inside of the scripts object. So we can run a build locally to confirm it. So we can run npm run build and it works. Happy days. So that's a kind of reason to kind of do it this way, is that we can control the build process locally as well if we want. So now we want to push everything up. Okay, so the next thing we need to do is change Netlify, not 11t, fix my slide, to run the npm run build command. So where we previously had 11t, we can put npm run build. Save that off. And now we want to push up all our changes. So we want to run git status. We want to add everything. We want to say git commit added package JSON, push everything up. And this push will kick off the build Netlify, a new one. And it should, if everything has gone well, publish. So we can see we have published here, and we can go check out our deployed application. And there it is. So that's Dotify running on Netlify, kind of globally. Anyone can see it. Sometimes when you click on view production deploy, you can get like a different hash in here, and you can be pushing up changes to Git and refreshing, and this isn't changing. And that's because it's a particular point in time. Just make sure you go back to your real URL that doesn't have a hash in it. I don't know if it's specifically a hash, but it's definitely like a string of characters that can catch people out. So is it a good idea to deploy from main? And it kind of depends on your operations process. Typically main can be locked to commits and only be an approved pull request is allowed to be merged. It's possible to set up Netlify to publish previews of changes too. So if it sees that you have a change or you have a branch, it could launch another site for that branch, and you could go check it out and make sure everything's happy and do some QA testing on it. Won't cover that here. And I suppose one thing, like I kind of skipped over, I suppose, is, what is Netlify? So Netlify just, it's a hosting provider. has a whole host of different features, like you might think of GitHub, but it's what we use to host tutors on, let's say. Um, so essentially, we're just using it as a kind of a compute platform now, or not even compute, it's kind of more hosting. And we're hosting a static site. And we've been able to build that into a Git operations process to do everything automatically. So they both have good integration, and that's kind of why we work with them. And you can get very far on the free account as well, which is the main thing. Um, of course, for things like tutors, we have a paid account and get extra features, security, blah blah blah. But so is that gitops? And it's like, no, it's only a tiny bit of gitops. We've essentially implemented naive continuous deployment. A CI/CD pipeline is typically made up of integration and delivery, and usually with a human in the loop to act as a human gate to a release to production. It can or can't, like that might not be all the time. And automated testing sprinkled into all these different places. And CI/CD pipelines can be made custom or off the shelf, and you probably shouldn't make your own. Been there, done that, regretted it forever. But there's products like GoCD, there's products like Team Server, can't remember what it's called, or Jenkins, continuous integration software that you can set up, to monitor your Git repos, run a load of tests when something is merged, a release is created in GitHub or Git, or a tag is created in Git, sorry. Kick off everything, deploy it to your staging account, run tests, deploy it to your integration account, run tests, and then deploy it to production, all automatically, or you have a gate in the middle. Okay, so that brings an end to like a quick introduction to GitOps. I'll advise in the lab to step through this and kind of add any more details, but I kind of designed the slides to just be something you can walk through at your own pace. So take up the slides, have a look at tutors, download them, that kind of thing. And we're approaching 2 hours here, so apologies. I don't intend on the rest of the videos for Web Dev 2 to be this. I just wanted to give you a wide kind of idea of what GitHub is, because you're probably sick of hearing about it without knowing too much about it. So I hope that has given you an idea. Feel free to step away from the GitOps stuff initially. Just kind of accept that it's there, or dig into it. People get really excited and enthused by it. But please play with Git locally, play with GitHub, and try and get the two to interact. Because we're going to be using GitHub during this module. Okay, thank you. As I said, we'll be back soon. We go through the module and hit the ground running. Cheers, folks.